Hello, and welcome to a Cloud Developer channel. In today's video, we're going to continue the topic of distributed session cookies using ASP.NET MVC Core hosted in Service Fabric. In the last video, what we did was to enable ASP.NET MVC Core session cookies, and the problem with that implementation in Service Fabric is because we have multiple nodes, each node has its own what's called data protection key that it uses in order to encrypt the session cookie information. And in a normal IS deployment, you would actually want to share that key, and typically that's done through a file share. But inside of Service Fabric, using something like a file share, even though it's possible, it might not be the best way to do it. So what we're going to do is we're actually going to build what's called a stateful service inside of our Service Fabric cluster. And we're going to build a little service implementation that's actually going to allow each node in a cluster to utilize that same session key from that stateful service that's available to all the nodes. So as you can see, this is the application that we built in the last video, and if I go to profile, I can type in login and the password, and I can see that I'm logged in. I can navigate to different pages. I can hit log out, and then when I go to profile, it forces me to log in again. So let's go ahead and go to our code, and I'm going to be doing a lot of copy and pasting because this is a fairly code-heavy tutorial, and then I'll try to explain as I go along in doing that. So the first thing we're going to do is we're going to go ahead and add a new service to our application, as well as a new project that's going to host some shared code for us. So the project or the service that we're going to be creating is going to be a stateful service, and it's going to be called sfcontacts.sessionKeys. And it's going to have a default session keys service. So we're going to go ahead and close that for now. And then we're going to add a new project that's going to be a classic .NET library, and it's going to be called sfcontacts.sessionkeys.domain. And this project is actually going to store some of our classes that are going to be shared amongst different services in our application. Okay, so we're going to add an interface here, and the interface is actually going to be for the session keys service itself. And we're going to go ahead and call it iSessionKeysService. I'm going to go ahead and actually copy and paste here. And then what you'll notice is it needs some packages to be imported. So the first package is going to be the Microsoft.servicefabric.services.remoting, and I've already downloaded it before, so it allows me to use the instance that I have. Or if you've never done it, it will go ahead and tell you to install it with the package manager. So I'll go ahead and choose the local instance, and it configures that. And then now it's also looking for the session key item, which is a class that we're going to be adding to our application or to this project. And this session key item basically is going to store the actual data protection key and the actual value. And the other thing you'll notice is that we have a constructor. We don't have any setters in the property. This is a way of controlling being able to actually create this object. So in this particular object also references another class that we're going to be using. It's called session key item ID. Let's go ahead and create that class. And I'll go ahead and copy and paste the values here as well. So it's pretty basic here. The couple of things that you need to know about this is this. First of all, it needs to be marked as data contract and having a data member. And this is going to facilitate the actual serialization of this object. It needs to implement the iFormatable, iComparable of session key item ID, as well as iEquatable session key item ID. Then inside of our constructor, we're going to initiate the ID variable to a new GUID. And then we're going to implement the compare to methods to allow it to compare to the session key item ID objects that are going to be passed in for comparison. And this is going to be used inside of the actual logic when we're going to be adding this session key item ID to a dictionary. So that's how it would actually know which values to compare against to make sure if it exists or doesn't exist when it's added to the dictionary. And then we're implementing the equals method. All it's doing is just doing an equals comparison on the ID variable. And then the implementation of the toString method with formatters being passed in. Now these methods on the bottom here are, at least what I remember, is they're really optional. You don't have to actually add them. I didn't find a difference when I didn't actually have to override these or implement these operator overrides. So we'll go ahead and save this. Go ahead and save the session key item, and then inside of our iSession key service, we're done defining all of our methods. Now the methods in this particular service are going to be GateKeysync, and that's going to actually return the count of keys that we have in our repository inside of our service actually. Then we're going to implement a method for add key as well as get keys. Now you could also implement the delete or remove keys. I didn't need it for the purpose of this demo, but you probably want to do something like that in order to keep your session keys in a manageable manner. So we'll go ahead and close this. And now we're going to go ahead and open up the session keys service itself. So the first thing we're going to do is we're going to go ahead and remove this default run async method because we're not going to actually be using it for anything. The next item is we're going to need to implement this method right here in a better way. Basically, we want to enable this particular service to be allowing communication from other services using remoting. So in order to do that, we're going to actually change this here to actually return a specific replica listener. So let's copy and paste that in here. And what this is doing is basically returning service replica listener. And we're going to be calling this method called create service remoting listener. The reason why this is actually complaining is because we need to implement a couple of one interface in particular, the one we just created, as well as import the remoting package as well. So let me go ahead and add the namespaces that are going to be required later on as well. And then I'm going to go ahead and add the iSession keys service. As soon as I do that, it's going to let me know that they can find it. But using the help from Visual Studio, I can just go ahead and click this add references to that domain project because it knows that it exists in that project. And then what we're going to do is hover over the session keys, and then we're going to, again, import that NuGet package. So in my case, I'm using the version that I already have. And then what we're going to want to do is begin to implement the methods for this particular service. So since I'm going to be copy and paste, I'm going to go ahead and remove this constructor that's here by default. The first thing I'm going to do is actually copy and paste the constant string. This string is actually a reference to the dictionary key that's actually going to be stored and accessed by this particular service from the partition store where the state is being actually kept for this particular service. So we're just declaring a constant string so that we can reference it throughout our methods. Then I'm going to go ahead and add the two constructors. The first constructor is basically invoking the second constructor, and the second constructor is invoking the base implementation of the stateful service constructor. So nothing complicated. All it's doing is basically taking the service context and passing that down and then creating a reliable state manager with that context, and it's giving it to the other session or service constructor itself. So then the next item, we're going to implement the getKeyCountAsync method. So actually, let me go ahead and paste all of the methods that I have, and then I'll just walk you through each one of them and what they actually do. So let me collapse that real quick. Okay. So the basic idea behind all these services is, first of all, we marked them as async and added the task class as well. So it's going to be returning a task of long. And the first thing we do is we actually obtain the actual dictionary using the variable we set up at the top here. And we do that by calling the base class's state manager .get or add async. And basically what this will do is ensure that if that reliable dictionary doesn't already exist, it will go ahead and create it and then give it to us based on the name. Then what we're doing is we're invoking the service event source, and this is a way for you to enable or implement logging within Service Fabric. And all we're doing is we're basically saying that a method on the session keys service called GateKeysync is actually being invoked at a particular time using UTC time format. Then we're initializing a variable that's going to be initialized to 0, which is the amount of keys that it currently knows about. We're validating to make sure that that dictionary is not null. And then we create a transaction, and then using that transaction, we actually invoke the dictionary to say, go ahead and get me the count of keys inside of that dictionary by leveraging that transaction. And this is actually needed to ensure that you're getting the proper data, because you're actually reaching out to something that is actually stretched out across your cluster. And then different nodes might actually be performing logic against that particular dictionary. So you're getting a point-in-time snapshot to make sure you're getting consistent data. So we get the count of keys. Then we log the fact that we ended the method, and then we return that count, and that method is done. So, and we do basically something very similar in the two other methods, which is add key as well as get keys. So in add key, again, we retrieve that same dictionary, reliable dictionary. We log the fact that the method got called. We create a transaction. And then the difference here is that we actually call the dictionary, and then we say add or update async. We give it the transaction. We pass in then the key item, which is that session key that's being passed from a consumer, in this case our UI application, and then the key item which needs to be stored by that node, and then we pass in this key item into this function here so that it actually stores that particular object inside of a dictionary using that key that we passed earlier. And then we call transaction commit that so that it can store it reliably inside of a reliable dictionary. And then we invoke finally the method to basically log the fact that the actual method completed at a particular time, and then we're done. So, and then the last method is, again, we're actually getting the list of all of the keys. The difference here is that we basically, once we get the reliable dictionary, we actually create a list to hold all of the different keys that we have stored inside of our reliable store. We create a transaction. We generate an async version of an enumerator. And then we go through that list and actually get all the values using the async method. And then we go ahead and obtain the value and store it in that results variable, log that we're done, and then return that value. So that's pretty much it. That's all we have to do in order to implement this particular service itself. So we can go ahead and close this out. And then the next item that we need to actually do is implement this inside of our UI application itself to start using it. So the very first thing that we need to do in order to start consuming it is to actually create what's called an iXML repository that is actually going to be used by ASP.NET Core to store these keys in, because by default it actually uses a different mechanism. So we're going to create a folder called security, and inside of this folder we're going to create our new class that's going to actually represent this new repository. And let me go ahead and paste some code here. We're going to go ahead and call this class SF Data Protection Keys Repository. I'm going to go ahead and copy and paste all of this logic here. And then, so what you'll see here is we're implementing the XML repository. We have a basic constructor. Right above that, we actually reference what's called a Fabric client. And Fabric client is a class that is part of the Service Fabric runtime that allows us to actually communicate with the runtime to obtain additional information. And you'll see how we're using it a little bit later. So the first method that actually needs to be implemented is this get all elements. This get all elements is basically going to return a list of all of the data protection key XML elements that's going to contain the value needed by each ASP.NET MVC core application to know how to decrypt the actual cookie values being encrypted. So this is kind of one of the main portions of the data protection repository that is going to be used. So what we do here is we actually create a new list that's going to hold the X element objects, which is basically a link version of XML element. And then we call this get all current keys, which is a private method right here. And all we're doing in here is we're actually just generating a new list of keys. We obtain a list of partitions, and this is where the Fabric client class comes in. So this get partitions actually invokes this method right here. And then we return using an await keyword to say, go ahead and give us the query manager, and then call the get partition list async, and it points to this key service URI. Now, this key service URI is basically the path or the address to our Service Fabric service that we just created, which is the session keys service. And then this is basically a URI to that. And the way we're constructing that URI is by actually using this helper class that we're going to create in a moment here as well. And this helper class, all it does is basically takes in the session keys or the actual service name itself, and then appends the actual application name that this service is part of. So let's go ahead and create that real quick. And I'm going to go ahead and actually create it at the root of this application. And I'm going to go ahead and copy and paste this in here. So just to quickly run through what this is actually doing. So it takes in that string for that service name. It calls the Fabric runtime and gets the activation context. So it basically is able to ask the Fabric runtime for additional information. It stores the service instance string that we're passing in, so it can use it in other methods. And then it basically has a couple of other constructor argument variations that you can leverage in here. And then it has the corresponding property getter and setters. And then the .toURI method is where the main logic happens. So we get the application instance name. Then we just strip out the fabric : / by replacing it with an empty. And then we construct the new URI essentially by saying, concatenate fabric : / plus the application instance name / and then the service name that was passed in. So that's pretty much all it is. And then this makes it easy for us to actually consume it here, because all we have to worry about is giving it the service name, and then the rest of it is actually abstracted away in this helper class itself. And then one of the next items that we do is once we get the list of partitions, we actually call that getAwaiter.getResult. And this is because this method itself is not an async method. So we basically force this execution from a async type of method into a synchronous type of method. Then we go through all the partitions that the service might live on, and we get the partition key, and then go ahead and create a service proxy. We point it to our iSession key service, and let's go ahead and actually add the reference to the domain project. And then we point it to this key service URI, which is the property right there. And then we give it the actual service partition key with the key that we obtained right above. And then we actually go ahead and invoke the getKeys method on the keys service itself. And then we force it to return from that partition. We add it to our list, and then we return the keys back to the caller. And let's go back to this get all elements. So once we actually get all of the current keys that are stored on all of the partitions within the service fabric from our service, we then actually parse the actual value, which is going to be an XML structure. We parse that value and add it to the list, and then we return a read-only collection. And this actually is being consumed by our ASP.NET MVC Core UI application itself to make sure that it knows how to decrypt actual keys. So that was kind of a really long explanation of that particular method, but I think it's very important to understand. And then the next portion is very similar, and this is where it's actually storing the actual keys that get created. So each node is going to invoke this method and actually try to add a key if it's new, at least to that node. And then inside of our service, since we do add or update and we have the comparison logic implemented, it knows that it just needs to update based on the key that's being passed in, and we're good to go. So here again, we get to a list of partitions, we get the partition key, we create a service proxy object, we actually create a new session key item that we're going to be storing. The friendly name actually is a GUID, and then we give it the actual XML structure that is being given to us by the invoker, and then we call the service to say go ahead and add that key. So once that actually completes, it comes back and then it gets out of this method, and we're done. So that's basically the implementation of this particular data protection key repository. And the next step we need to do is actually go ahead and hook it up inside of our application. And we do that by going to the startup class. And inside of the startup class, what we're going to be doing is we're going to be adding or actually overriding the default data protection key logic. So we do that by basically referencing or calling this add singleton. So basically anytime anybody wants to get a reference to XML repository, we're going to return an instance, a singleton instance of this data protection key repository. So let's go ahead and add the using statement here, and we're going to add a using statement here as well. And so those are done, and then we also need to add a using statement to enable this extension method as well. So and here basically what we're doing, this one is actually adding the singleton for a repository, and this call right here is very important. Basically when we're actually calling add data protection, this is actually going to override the default behavior within your ASP.NET MVC Core application, and then force it to actually load up this particular repository. And then you're actually setting the unique name of the application within a data protection system that's going to be used throughout the instances of your application to know which one it's actually dealing with. So which data protection mechanism to actually be using for this application. So now that we have this integrated, we are able to actually start consuming the information in here. So what we're going to do is we're actually going to enhance some of our controllers as well as our views to be able to display some additional information. So I'm going to go ahead and quickly open up some views so we can actually start adjusting them. So let's go to our profile controller. And the first thing we're going to do is we're going to actually go ahead and add this Fabric client again. And this is going to be referenced by this particular controller. So I'm going to go ahead and add the namespaces. And then what we're going to do is, again, this is going to be somewhat of a lengthy piece of code here, but I'll walk you through it as well. So what we're doing here is a few different things. One is we're, again, instantiating that service URI builder. We're pointing it to the service itself, which is the session key service. We're obtaining the actual service name. And then here we're calling the Fabric client query manager to get the list of partitions, just like we did in the other implementation. So, and here what it's complaining about is I need to actually turn this into an async type of an action. Once that's done, it's happy. So once we get the list of partitions, we're going to create a variable that's going to hold our keys. Then we're going to go through each partition, get the partition key, create a service proxy instance, and then we're going to call it await, get keys from that key service, and we're going to add that to our keys list that we generated above. And then we're going to go ahead and store the keys inside of the view data under the key protection keys. And then also what we're doing here is just for troubleshooting purposes, and this is important as well. I'll show you, how it actually works. And one issue that I ran into that I'm going to be opening up a bug for. But basically, we're storing the keys, and then we're actually building a list of key value pair for the cookies that are coming in through the request, so we can actually render that information on the screen. So we're going to set that to the view data cookies key, and then pass the cookies that we obtained from the request. And then we're going to go to our account controller, and inside of our account controller, we're going to go ahead and add some logic into the login method as well, so that we can see the cookies as well as we can in a profile. So in here, basically, we're, again, creating a dictionary. We're going to the request cookies and setting the cookies. Now, one thing that we're going to add actually here is inside of our logout method, we're going to actually try to clear some cookies. And I'll show you later the issue that I am actually discovering inside of Service Fabric. So in here, in the logout action, we're actually going through a list of cookies that we have in the request. And then we're checking to see, do we have any cookies that actually have this cookie authentication string inside of it? And if we do, we're going to try to delete the cookie, because the thing that we're trying to do is when somebody logs out, we want to make sure that that authentication cookie is no longer there. One would think that calling authentication sign out should be enough, but there's actually a problem inside of the application gateway that I believe is going to be addressed soon, and I wanted to show it to you. So in this particular implementation, I think we should actually be ready to start testing. So let's go ahead and actually have the local Fabric cluster already running. So let's go ahead and open up this manager or Service Fabric Explorer, and we'll go ahead and actually run this application, make sure it actually compiles, and we'll go from there. Okay, so as you can see, the application started. So I'm going to go ahead and open up a new tab, and I'm just going to go to the local instance of this application using the application gateway URL. So our application started, and then if I can basically go ahead and kind of walk you through it real quick. So as I keep clicking, everything seems to be working. I click on profile, and then we should actually be able to. Right, so I forgot to actually update the views in order to actually display the information. So let's do that real quick. So in the login view itself, we're going to add some logic to obtain the actual cookies. And then we're going to add the cookie information right in the middle here, or at the top. So all we're doing is basically casting that cookies as a dictionary string, and then we're going to create a h2 tag saying cookies, and then go through each cookie and actually output the key and the value. And then inside of our profile controller, we're going to do something similar, but we're also going to add, sorry, not controller, view. In here, we're going to actually add similar logic, but we're also going to display the actual keys as well, not just the cookies. So we're going to add two variables here. That's going to be the keys and cookies. And then we're going to add the actual rendering portion of this. So here we're getting a list of cookies, we're rendering them, and then we're getting a list of keys and we're rendering them as well. And we also need to make sure we add the using statement to the session keys.domain class because it's being used right here. So now we should be ready. Let's go ahead and hit start and see how this works. Okay, let me go ahead and restart this application again by going to that main URL. Okay, so when I click profile here, we should actually see some information. So you can see I actually have some cookies already listed out right here. And then if we open up the dev toolbar under the application section, you'll actually see that we have information here as well. So let me actually go ahead and clear my cookies real quick. And then let me go ahead and refresh. So as you can see here, again, we actually are showing the fact that we actually have some cookies being generated or sent to our application from the actual application proxy. So if I go ahead home and go basically just click around, you'll see that the information is actually being outputted here. So what we're going to do is we're going to go ahead and log in. And then what you'll see is now I actually have the current user showing, the actual current claim object showing, and then we have the cookie authentication, so aspnetcore cookie authentication, and this is the value that's actually being stored inside of the cookie. Also, we have this anti-forgery cookies listed right here as well. And then what you'll also see is the actual keys that are being used by our Service Fabric cluster. Now, this is a local single node cluster, so there's really not much benefit. Even though it's communicating with the service, it's really not buying us much. So, but we actually see the key information, the data protection key information in an unencrypted form. So this is important. You want to find a mechanism for you to be able to actually store these values in an encrypted fashion. Otherwise, if somebody actually obtains the access to your session keys service, they can invoke this and start decrypting your keys. So you want to find a mechanism to actually be able to encrypt them in a secure manner. You wouldn't want to persist them in a database in an unsecured way. So, and then what I'll do is I'll go ahead and click logout, and then when I try to go back again, you'll actually notice that the cookie authentication cookie is no longer there. So that's why it actually is asking me to log in again. So if I go ahead and log in, you'll see that it shows up. Then if I actually go ahead and close the browser and then try to navigate to that application again, go to profile, you'll see that I still have my cookie in the system, and it's allowing me to actually reuse the session, and I'm able to log in and use it like I was right after I logged in. So if I go ahead and click logout and click profile, it clears it out. Now, the next step is let's actually go ahead and deploy it to our cluster, our multi-node cluster, and see what this does in the cluster itself. So I'll go ahead and publish this to my cluster. Go ahead and hit publish, and let's watch it actually deploy. So it hasn't deployed yet. And you can see that my application is actually deploying right as we speak. So what I'm going to do is I'm going to go ahead and scale this UI service out to the 5 nodes so that it's deployed across all 5 nodes in my load balance configuration. And then in a moment here, all these nodes are going to actually start showing that everything is working. And we're going to go ahead and actually warm up our application by trying to navigate to all of the nodes fairly quickly. So the way I'm going to do that is I'll just, since I have this link right here, I can just start clicking this. And because we're using the NLB, it's actually bouncing me between the different nodes in a cluster and beginning to invoke the actual startup logic, the warm-up logic inside of our application. So you can see on the bottom here, I'm already beginning to load balance between the different nodes, and the application is responding. So far, I've hit, looks like I've hit pretty much every single node. So let me go ahead and hit profile here, and you'll see that, again, I have my AI user cookie, and I have the anti-forgery cookie. No other cookies actually exist on this cluster. And then everything is looking good so far. So I'll go ahead and log in here, and you'll notice that this is the first time I'm actually showing you that now we're actually invoking a service, and the nodes in the cluster are actually using this repository for the data protection keys. In a prior video, what you saw is the actual act of me clicking login actually took me to another login form because it actually load balanced the request to another node in a cluster. But as you can see here, now that I actually have the shared repository, it actually put me on another node, but the information is actually still stored. So if I start monitoring this host right here on the bottom and keep clicking profile, you'll notice that actually I am going between the nodes in a cluster, which is basically the purpose of this demo, is that we're actually going between cluster nodes without having the user know that we're actually hitting different application nodes, which is perfect and exactly what we wanted to do. Now, the problem that I actually discovered is that we're actually going against the application gateway service. When I actually try to hit logout, everything should be working the way it's supposed to be, and when I hit profile, I should always be taken to the login page until the user logs in. But what I've discovered is that periodically you'll actually notice that additional cookies end up showing up when I'm actually hitting the application node. As an example, this cookie right here was actually something that I was testing with prior to doing this video, and it actually showed up on one of the nodes, but only one of the nodes, not the other one. So if I start refreshing, you'll see that some of the cookies actually disappear. Now, there was a bug open in Service Fabric, and they were supposed to actually fix that bug as it was closed, but to this date, there wasn't an update that is accessible, at least not that I've been able to discover how to access it to update my Service Fabric cluster. And the issue that I'm dealing with right now is essentially, as I continuously start going through the nodes, you'll see that the cookie authentication is still here. However, it's actually not allowing me to get to the protected version of the actual page, even though the actual cookie itself is actually here. So, which is kind of interesting. And as you continue bouncing between the nodes, sometimes you'll actually see the behavior that the user ends up actually logging in, as you just saw right now. So one of the nodes actually thinks that I still have a fully authenticated session. So this is a pretty big security issue, at least in my opinion, but supposedly this is actually addressed. And this issue in particular is actually caused by the application gateway itself, because it seems to be actually persisting the cookies and the way that they're actually being passed in to the actual individual nodes inside of the Service Fabric cluster itself. So when I actually figure out how to obtain the latest version of the runtime, I'll actually be posting another video and showing you how to actually upgrade your Service Fabric cluster that you already have to the latest version. So stay tuned for that video, and hopefully this was an interesting topic for you, because to me, having a setup like this in Service Fabric where you have an application that's highly distributed across your cluster, as you begin to scale it out, all of your nodes can actually be load balanced in a very reliable manner, and all of the data is actually being stored correctly inside of a shared service. And then later in the future videos, I'm actually going to be building another function that allows you to store your actual session information, not just authentication cookie, but end user session information inside of what's called a reliable actor. And this will allow you to actually track information and state about the user, that user doing something with their account information, things like that. in a way that is accessible to every node in a cluster, but only for that given user. And if you add more users and remove users, that logic will actually follow, that state will actually follow the user throughout the actual Service Fabric implementation. So this to me is a very interesting POC to actually do and see how people end up using this in the real world scenario. So if you have any questions, go ahead and leave your feedback in the comment section below, and I will talk to you next time.